This is section 4.5, number 3. It says find a formula for the exponential function shown, and we're given a couple of points on the graph, so let's go ahead and label them. So the first one is 3, 4, and the second is 6, 12. Well, the first thing that we want to do is try to figure out the y-intercept, which is not marked. Even if I do mark it, it's not clear exactly what it is because it doesn't look like it's an integer. So I think we can figure it out by comparing the y's that are given and then kind of going backwards to figure out what that missing y coordinate is. Okay, so to get from 4 to 12, multiply by 3, and therefore to go backwards to get from 4 to this y value, we're going to divide by 3, so it'll end up being 4/3, or 1 1/3. Now, the reason we can do that is because the difference in the x's is consistent. Okay, so if we look from 0 to 3, there's 3 spaces, and from 3 to 6, there's 3 spaces. So this change in the y should also be consistent. Okay, so our function is of the form f of x equals a times b to the x, where a is the y-intercept, which is 4/3. Okay, we do need to figure out what b is, and so for this case, we're going to look at that difference between the y's, which was a factor of 3, but that happens over the course of 3 x's, and so really we're going to use this formula y2 divided by y1, and then to the 1 over x2 minus x1. And so we end up with, say, 12 divided by 4 to the 1 over 6 minus 3. Or 12 divided by 4, which is 3, and then 1 over 6 minus 3, that's to the 1/3. So altogether, we have our function f of x equals 4/3 times 3 to the 1/3 to the x, or you can just write to the x over 3.